the break, whatever day that is. What? After the break. Oh, never mind. Right. Here, I'll show you the calendar. This is the day before Thanksgiving. I'm guessing you're busy, and we won't be here. The 29th will be when we'll do the brain dissection. I'll probably do a little introduction on the cranial nerves. Then, and then this will be the final. And then you're done with me, at least many of you, until after the first. Yeah, don't make me sick.
I like your shirt.
My wife has the queen one, of course. The king and the queen. Yeah. Yeah, the trouble is I splattered bleach on it when we were doing our pool, and she's mad at me. Very, very angry. So I these days I wear a lot of layers. It's cold in the morning. It's around here. We're only going in the wrong direction. So here's what we're gonna do. We are. So I'm gonna. I would guess you're doing central nervous system in lecture. Okay, so a lot of this stuff is. So I'm not going to try to repeat it. I'm going to try to highlight it more than anything else, and we'll go from there. So you'll get through that, and then you should get through at least autonomic by the end of the term. And that's very much a physiological, not so much of a mental thing that's going on. And so let us begin, as it were. Make sure we're all good and recording. So for those that may have not been here, and I didn't really find, I still don't have my computer. They're supposed to have it done today, and I'm a little disappointed. So this is now it'll be on the recording when I finally get them processed and sent to you. This is last year I did this. It's the same thing I drew up on the board last time, if you recall, and I had taken a picture of it previously, so I wanted to put all of that out there for you. So basically, it's my sort of schematic breakdown, just to refresh your recollection of what goes on in the cerebral cortex. We're going to talk briefly about the lobes that are there, effectively the basal nuclei, kind of their impact on Parkinson's briefly. So diencephalon, and then touch on something called the limbic system, which is sort of your emotional, and there's a lot of areas where emotion is part of it that are there. And then this is the brain stem, midbrain pons and medulla, which are autonomic. We really don't have any control over that whatsoever. The very interesting cerebellum, which sort of gets all sorts of information about body movements and processes them. To recall them, what you have to do on one side or the other. So it's ipsilateral, fancy word, which means movement on the same side. And what this is, it really gets information from what are called, and I don't know if you touched on them, they're called proprioceptors. It basically, if you close your eyes, we all know where, you close your eyes, you know if you're sitting or standing, you know where your arms are, you know if your head's facing forward, if it's turned to the side, you know if your hands are in your lap, or if you're up on the tabletop, on top of a laptop. You all know that without looking. You should. Okay, that's called proprioceptors. They tell you where your body is. We need those in order to basically kind of know where we're going. We need to have that information along with our eyesight and the coordination of the cerebellum. There are three things. Two of those three things are necessary. So it's easy enough since my sensors are there telling me where I am. My cerebellum is processing, so it knows where my feet are. And with my eyes closed, I can certainly look forward or backwards. Or if there was something wrong with my cerebellum, or if there was something wrong with my sensors, I could watch and kind of move this way. And that's how somebody walks, and they don't really diabetic because they don't get their sensors and their feet don't work. So you only have 2 out of 3. And the fancy name for this, and I wrote it over there, it's called Romberg's song. Why is that important? So none of you should have any experience with this. It's basically they do the drug test to feel sobriety. So what do they tell people to do? close your eyes and, put your finger to your nose. You and I can all do that, unless you can indulge it. Prior, which, good. Glad to hear that. Okay, so what do? All of a sudden they do that, they touch your ear over here, they fall down laughing. The cop's gonna be really unhappy with you when that happens, so don't do that. But that's what Romberg's sign is. It's basically being able to assess whether or not, if you take away two of those, because alcohol takes away the cerebellum. So I figure I'd throw that in there, and now we'll get on with the rest of the program. So again, I'm going to try to do this buzz through style, so we can dedicate a fair amount of time to the dissection and less time to chatting about it next time. And again, I'm hopeful that tomorrow they'll have my computer so I can do more of this stuff, or else I'm going to have to come back here over the break, which I don't want to do. So we start here. Just a quick review of the lobes. The frontal lobe here, highest order processing, language, calculations, motor movements, all of that. It's rather intricate because there's areas where you basically are able to plan what you're going to do and then do it. And I'll see that in a second. Parietal, general sensory information. So if your arm is on the table, you can feel if it's a sharp edge, a dull edge, if you have something in your shoe, that type of thing. Temporal, balance and hearing, occipital, a vast amount for vision. Deep inside, if we sort of look inside, and you'll see the illustration, something called the insula. It's relatively primitive. Things like smell and to some extent aspects of taste are relatively primitive. Okay, you'll come to learn that smell particularly is something, ours is pretty good, animals is even better. And it's why we can use trained dogs with regard to scent. I don't know about you, at my house, if I grab something to eat, the dog could be in the other room, and the next thing I know, there's a head on my knee. What are we having, Dad? It's snack time. I can't hide it. You're trying to dog nose. So the name for the bones is, you knew that. Won't do the pictures. Here it is. So if you take a little section, the cortex is the gray matter close to the surface. This is something you can see on us, you can't see on the sheep, because the sheep brain is pretty darn small. So what we're going to be working with, kind of looks like this. That's the sheep's brain. Hey, the sheep isn't that smart. The sheep brain was bigger, he'd be operating on us. Yeah, there's a box down there. But they're not in the fridge. Sorry. Here it is. This is a sheep brain. So this brain actually has, I think this one does not have the linings around it, the meningeal layers. That's what they're working with. So maybe it's about a third, maybe a quarter of the size of ours. Sheep's not really. Hey, what do you say? And so, why it isn't refrigerated, we get all our stuff pretty much in Carolina labs, a lot of things. And Carolina came up with this stuff called Caroshape. In the old days, we used to put formaldehyde in it to glue down. That's when we had to use the hood to do formaldehyde-based specimens. Now this stuff theoretically makes it, if you term sanitized, but not harmful enough to just throw it away very well. You can smell some stuff in the red bags today. So that's what you're going to be. It's small, and I have some good illustrations for you. So things that you won't see as much definition. You'll see these mounds and crevices called gyri and sulci. You won't make out this central sulcus. That's the divide between sensory and motor. So where you initiate motor control is called the precentral or primary motor gyrus. when you plan to do something, well, I'm going to move my arm for a gesture, it's coming from here. So this is like an associated or a planning area. Same thing with sensation. We sense my keys are here. I can feel them in my hand where they're sharp. How do I interpret which key it is? Maybe I feel for one's flatter or whatever. That's over here. And this area in the darker blue, that's the temporal lobe. And in this yet lighter over here, that's the occipital lobe. Deep inside here is this internal layer we call the insula, which is even more, the deeper you go, the more primitive it is, so to speak. So there's a lot of these that you won't see, and we don't need to go into them at this level. So each hemisphere has the cortex, which is the highest order and the heaviest, the greatest concentration of cells. The white matter, which we'll talk about shortly, which is how it communicates. One area communicates with the other. And deep inside, some additional gray matter. These are the basal nuclei. Again, they're a little bit more primitive because they have a bit to do with sort of motor control. And when they're damaged, it makes motor skills starting, stopping, doing things smoothly without jittery and stuff like that. That's the association with Parkinson's disease. And again, Parkinson's disease is, I think, it's more of a global term because it basically implies the disorder. It really doesn't tell you, is it a virus? Is it brain damage? Is it a stroke? Whatever. Okay. Side effect from medication. So this is everything for us. Okay. That thin layer, barely 1/4 of an inch thick, is very, very heavy comparatively. 40% of the mass or the weight of the brain. And we have been able to analyze it for a variety of years. And what they do now is they use scanning techniques. So we have the luxury of scans in color. When I first started in this game, 50 years ago, I matriculated in medical school 50 years ago this fall. Okay. It was x-rays. And if you wanted to get a little information, you injected some dye into an artery or a vein and see if you could outline something. This is a functional MRI. You can do the same thing with a PET scan, positron emission tomography. And what that means is when somebody, it basically they're radioactively tagging glucose, and when the glucose is busiest, it turns colors. So if it's not busy, it's green. But here's your occipital lobe when you see something, your temporal lobe when you hear something. This is a neat layer. Maybe you did it in class. When you and I communicate with one another, this has got a fancy name. It's called Broca's. Did you do Broca's area? Capital B-R-O-C-A-S. Broca's area is where we communicate. We form. It's not so much form the words, we decide when I'm thinking about how I'm going to express something to you. When someone has a stroke, most of the time strokes affect motor. They have difficulty moving, they have difficulty speaking, they have difficulty communicating. And it's not just talking. It's not like, well, if you can't speak, then I'll give you a pencil and a pad and you can write it down. Can't do that either. So we call it, it's got a fancy name, it's called an expressive communicating or expressing yourself, aphasia. A-P-H-A-S-I-A. Back here in the temporal lobe, you have receptors. And it's another fancy name you'll see in shortly. It's called Wernicke's area. That's called a receptive aphasia. Like you can hear perfectly, but the trouble is you can't make any sense of the words. I could say, is it a nice day outside? And you go, yeah, today's Wednesday. That's what kind of happens when people are affected there. It's almost like they're trying to guess what you're saying. Very, very interesting. So you can see when you're thinking, it implies all of those areas. Okay? And so we look at those types of things. When they talk about lateralization, typically most of us have one side that's more dominant than the other. And again, it's contralateral. So if you're left side dominant, your right hand is about 90%. That oftentimes is associated with things. Certain people are logical, mathematical, verbal, analytical. I'm as right side dominant as anybody. Left, when you're right handed or left side dominant as anybody. People who are left handed often, though I don't think you can paint with a broad brush, are more creative, artistic, musical. I am none of those. Like I said, I'm right sided all the way. My sister's is left handed, is very logical, mathematical. She's got a master's in business. Yeah, go figure. Yeah, I hate it when we, look at that type of thing. So there's lots of different areas. I'm just talking about some of these, and we'll analyze them as we go on without getting into too much detail. Here's that Broca's area that I'm outlining with the cursor. Here's Wernicke's, which sort of overlaps temporal and parietal lobes. So we'll look at what happens. Like, for instance, they call this the frontal eye field. This is where we're starting to be able to interpret what we're seeing. And then this is perhaps the most fascinating area here. This general, almost forwardmost area of the brain is called the prefrontal cortex. Years ago, and it's very sad, they thought that this was where behavior. We know that behavior is more complex. So you can YouTube watch it. You can watch it with commercials on any one of a number like Flex or Tubi, all these different apps that are free. If you haven't already seen it, watch a movie called One Flew Over the Cuckoo's Nest. It's made in 75, 76, that area. It won Academy Awards for Best Picture, Best Director, Best Actor, Best Actress, Best Writing, blah, 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 blah. All that type of stuff. It won all of them. Okay? It was Jack Nicholson playing effectively a crazy criminal, and they put them people in hospitals for the, quote, criminally insane. And what they did when they couldn't deal with electroshock therapy, which has its place, but mostly for depression, when they couldn't deal with them, they did what's called a prefrontal lobotomy. They took out parts of this, and they basically created a walking zombie without any emotion or behavior or anything like that. Fascinating. That was the first time we saw, in that particular cast, Christopher Lloyd, we may know, or Danny DeVito, who you see now in all those Jersey Mike's commercials now, very diminutive guy. So they put a lot of these very interesting people in this movie for the first time. So it really, if I was doing like behavioral psychology or abnormal psychology, that would be appointment. That would be part of the curriculum, because we've depicted a lot of these things in the movies. So that's a little note about this prefrontal area. They talk about it a little bit more. Okay, where you go over here when you get to this, and I cover it in my A&P1 when I do that. Basically, this is how you initiate. I'm going to pick up my keys. Okay, it's called that motor cortex or primary motor cortex. That's there. The cells it's a 2-nerve circuit. You have a nerve that goes from that part of your brain to somewhere in your spinal cord, and another nerve that goes out to the muscle. Okay, it's called the corticospinal tracts. Another name we give them because of where they're located in the brain, mounds on top of the medulla, they're called pyramidal. Corticospinal tracts. And we can map out both motor and sensory on our brain what goes where. Here it is. It's got a great name. It's called the homunculus. So in red is motor and blue is sensory. And so think of this as that lobe in front of the central sulcus and this lobe behind it. This is the center. So what do we move to communicate with the world? Head, face, mouth, tongue, upper extremity, maybe a little lower extremity. That's about it. Okay. How do we sense the world? Mouth, facially, upper extremity, maybe a little lower extremity, etc. You can see how much sensation we get from the abdominal cavity. Not a whole lot. That's why when you have a stomach ache, it's all over. You say, where, oh, my stomach hurts. Where is it? They'll point down here. Stomach's not here, not here. They'll point to 10 different places if he has 10 different people. It's a way of, but if you got a splinter, in your finger, you know exactly where that is. Because look at how much the brain is dedicated to that. By the same token, if you want to make an intricate movement, most of us can do so. If you're sewing something or threading a needle, let's say. My wife's good with that. My first wife, I always had to thread the needles. She wasn't that good. My wife now is a seamstress. She is very, very talented. I told you about that goose clothes. Yeah. One of those. She's got all the creativity I have none. So premotor, you plan it, okay? Broca, communications, mostly on the left. Voluntary eye movements, so you do things with our eyes constantly. I look out here at you folks, and I get ideas whether you're paying attention to me, whether I'm being interesting or being dull. Mostly it's dull. So that's why I have to do something silly to get your attention. Okay, but we do that all the time. This is the interior. This in white is white matter. This is a communicating channel, so the right side of my brain knows what my left side is doing. It's got a famous name. It's super thick. You'll see it on the dissection. It's called the corpus callosum. Within it, you're going to see one of those ventricles, one of those fluid-filled areas, and within that, you'll see more gray matter. Those are the basal nuclei. These interior gyri, this looks like the letter C. It's called the cingulate gyrus. That's there. Okay, so you have a lot of different, this is part of smell down here in the temporal lobe area. So that internal or inner portion, we sort of split the brain this way and open it up to see what's going on. It's very interesting. And so all of this is, when someone has brain damage, or what we call a stroke, a part of the brain dies, inevitably, it typically affects motor more so than sensory. And you're paralyzed. You can't move that area. Yes.
How exactly done?
Pardon me?
How exactly done?
Usually from not having enough blood supply. So it either part is damaged. Most often a stroke is where a blood vessel is blocked or a blood clot forms or travels to. That's the most common thing. Now there's other things, of course. You can have tumors will affect it, infections will affect it. Sometimes we really don't understand. But by far away, most often it's blood supply. By the same token, if a blood vessel bursts, that blood will accumulate. It's got nowhere to go in the skull, and it pushes. It's like it squeezes it. Okay, everybody? And that destroys it too. So it's a fascinating type of a thing that goes on. A lot of times it's supply and demand. That happens in your heart a lot. A heart attack doesn't mean that there is no blood supply, though frequently it is. Sometimes it's that, and we'll see it in the winter every year. The first day we get that wet, heavy snow, somebody who's been sitting doing nothing, I was going to say something, sitting on their large posterior, basically, and goes out and decides to shovel and keels over with a heart attack. That's a match, supply and demand. Most of them, they're very vigorous and they don't have the blood supply to support it. But when they went out there, they had a cigarette in their mouth. I used to do that stuff, so I can tell you. So a lot of that. So there's, again, I won't go into all that. That's more physiological in the interest of time. Vision is in the occipital. There's a lot to this. And to me, it's more physiology. And whoever's doing your lecture, how much they want to cover is up to them. That's there. And again, auditory areas are basically in the temporal lobe, as is balance. Because the balance and hearing kind of go hand in hand anatomically. That's the vestibular cortex. Vestibular function is balance. Okay? And olfactory is smell, also temporal, but even in that primitive area, the insula area that's inside, smell's very telling. And we'll learn about that when we look at the cranial nerves. That's why when somebody's, looks like they're comatose, maybe that's the wrong word. Somebody all of a sudden looks like they're knocked out or they're losing consciousness. What do we use? Smelling salts. Some very, very strong smell, usually spirits of ammonia. Years ago, when in my office, to get a medical office, you had to have in every treatment room smelling salts taped to the wall and a padded tongue blade in case somebody had a seizure. So every room I had that. So if I had an office with 3 treatment rooms, they were in every one of those rooms. Don't know about now. Taste in the insula, that visceral area is not a whole lot. You don't get a whole lot. And so, and this just tells you these interesting areas. This talks a little bit about the prefrontal, very complicated. All of the things, it's kind of, it's almost like let's say I think of something clever, and I all of a sudden I see somebody react adversely to it. And I don't want to offend somebody. That's kind of like what that area does. You're sort of feedback from social environment. When you're looking at me, did I say something wrong or incorrect? And I'm immediately smart enough to apologize or at least indicate that there was some problem with it. So that's that area that they used to remove, thinking that had to do with behavior. It really doesn't. Okay? It involves a lot of things that we do as we interact with others. Because I think you have to be careful with it. Boy, these days people take offense fairly easily. I'm so happy, not for you, but for me, that I didn't grow up in the era with the social media and all that stuff. Because it got to go drive you crazy. You know? Oh my goodness. So we'll look at all of that type of stuff there. I'm trying to get through this. This is the idea of right and left. It's called lateralization. 90% left side, right-handedness most of the time. Language, math, me. Okay, right hemisphere, visual spatial, I have none. My children, when video games came out, we had the first Super Mario Brothers in the 80s. Maybe you've seen it. No, you Google it, they'll show it to you. My boys were in 6th and 5th grade, 6 and 5 rather. They could beat me. No visual spatial skill. No artistic and musical skills. See ya. Moving on, easy. Told you we're going quick. Quickly. If that's a word. Hey, you can't have enough syllables in a word. Voila. Number 2, white matter. 3 types. White matter have nothing to do with processing. It's just moving it from point A to point B. So you have what are called commissural fibers. That's that corpus callosum. It's really the only one. It is basically right side telling the left side what's going on. Projection, up and down. Association, same side. What did I just see? What does it mean? How do I react to it? Okay, that's kind of how it goes. So they have a good idea. Association fibers, same side. Commissural, across. Projection, up and down. There's a couple of very specific. On the dissection, this is corona radiata. We're all familiar with coronaviruses because it has a crown. You'll see that in micro. The external enclosure, okay, appears to have a crown-like appearance. This corona comes off an area called the thalamus, and it's white matter fibers that basically direct senses to the appropriate place. If I stepped on something with my foot, it's got to go to the part of the brain that senses my foot, not my finger. You'll step on a piece of glass and go, wonder what I hit. Doesn't work that way. That's the idea. So it's radiating crown is what that means. And the internal capsule is fibers that are basically dealing with movement and sensation. So here they are. So you can see that you can actually do this. You can slice a brain sort of the long way and take a look at the corpus callosum in green. They depict it here. association fibers like this, and then the up and down fibers. So here you can see parts of this internal capsule. This is the area of the basal nuclei, and the corona radiata. This is the thalamic area, and it's basically directing to the appropriate area of the brain. They show it to you again here. This is what it looks like. It almost has like I've seen this because some of those specimens are better than others, and it's almost like a seashell-like kind of a thing, the way I would describe it. There's not a lot to say about the basal nuclei. They have a lot of areas. I'm not going to ask you about any of it. They're internal areas of gray matter. So on the dissection, if you look inside the ventricle, you'll see gray matter. That's what this stuff is, and it plays really an important role in movement. When anatomists sliced it, okay, it looked kind of striped. So they began to see, for whatever reason, they looked at this and called it striate or striped in appearance. And so a lot of times they'll refer to it as the corpus striatum. So I don't know why, but that's what they did. But you see what it does. Has some action on muscles. Plays a little role in thinking and emotion. What we do for slow or stereotype movements, what would that be? So let's say you're by hand mixing a cake recipe, for instance. So unnecessary movements. So it plays a whole lot of role. And if you've ever seen somebody with Parkinson's disease, they have what we call a flat affect. They kind of look like this. You have people who are teaching you who are like that, I know. Right. Look at the board. That's the letter A. I could do that, but I don't want to put people to sleep. And famous diseases, Parkinson and Huntington's disease. You ever hear of Huntington's disease? Right. You must have had that. You did? Huntington's disease is a movement disorder. We used to call it Huntington's chorea, not the country. Chorea are different kinds of movement. And so they had a particularly irregular form. It's a genetic disorder that's passed on dominant. So if a parent has it, you have a, guess what? 50-50 shot of getting it. Not good. And you don't find out until you've already had children yourself. It doesn't typically demonstrate until childbearing. So there's a famous folk singer named Woody Guthrie who passed it on to one of his children, but his other child, who was another folk singer named Arlo Guthrie, had a number of interesting songs during the late 60s and early 70s, is still alive. So we see that type of thing. It's very interesting. When people had this, they thought this was an affliction from the Almighty. So they called it St. Vitus's dance, interestingly enough. So that, with these herky-jerky movements. So if you look on Huntington's disease and look for videos, you'll see there's a whole cluster of folks who have married each other because it's a relatively isolated community in Venezuela in what's called the Maracaibo Basin, where they did a lot of the initial research on. See, you learn something new every day. And we actually are starting to be able to treat this now a little bit. Okay, the diencephalon. This is subconscious. Thalamus, basically a relay center for sensation. Hypothalamus. This is the connector between your brain and your endocrine system. This is where the blood-brain barrier is weakest. Sugar, salt, chemicals like testosterone, estrogen, and progesterone that we utilize to measure and basically govern reproductive functions. All sorts of things are sensed here and responded to either by the brain or through your endocrine system, which you'll learn about next time, by producing hormones to deal with it. Okay? And the epithalamus, which you will see, this is very tiny on the dissection. This you'll see, the epithalamus, sometimes called the pineal gland. Some people pronounce it pineal, but it was named because it looked like a little pine cone that we see now. Just come to my lawn, you can see pine cones. And if you want to rake leaves, we put out, are you ready, in the last 2 giant cans each Monday, plus, count them, 28 bags of leaves. All the leaves come down into our lawn. Terrible. So they're over here. Now all this big stuff out of the way. Here's the thalamus. Here's the hypothalamus. Here's the pituitary coming off it. This is called the optic chiasm. We'll talk about that next time. Here's the pineal gland. You'll actually see this. What we're going to do on the brain is we're going to look in this area between the cerebellum and the cerebrum, and you'll actually be able to see that structure. This is the second largest area. This is the cerebellum. This is the rest of the brainstem. You'll see here, it's got a very interesting white matter that's there. That is called the arbor vitae. Okay, see the name? Arbor means tree, vitae means life. So anatomists thought that was really the critical area of the brain. So they called it the tree of life, or in their language in Latin, arbor vitae. So it's over here. But again, the cerebellum is processing all those movements of where our body is and communicating it sort of up and down. That's there. So here's the thalamus, mostly gray matter, all in here, and then directing those fibers, relaying it, editing it a little bit from different areas, from the hypothalamus, plays a role with emotion, internal functions, cerebellum and basal nuclei for movement, sensory integration. So it mediates a great word. It kind of processes and tells you, oh, this is important. Or it's like by now, that noise over here, most of us would ignore. That's kind of your thalamus going, yeah, don't worry about that. Background noise. The hypothalamus is below it, tiny mammillary bodies, because they look like, on the sheep, they're too small, like little breast area tissues. And there's a little stalk that comes out of this part of the brain, and that's the back of and the attachment to the pituitary gland, the single most important gland that we have from an endocrine perspective. And indeed, one of the questions I asked you on the practical was about the sella turcica, that little saddle-shaped depression. That's where the pituitary sits. So these are all those sensors for all those chemicals and other values. And then here's the little stalk. And the pituitary, the back part, is actually a gland, but it's really part of the brain. And the front part is what we call the pituitary. So controls blood pressure, heartbeat, pupils, digestion, part of the limbic system, which means it plays a role in perceiving pleasure, fear, biologic rhythms, sex drives, all of that. So it's for a tiny area, very important. Body temperature, hunger and thirst, water balance, all of these things, biological clocks. We all have, it's sort of a timing thing, and the pineal gland does the same thing. So if you're, like most of us, you guys here are mostly daylight people, right? You go to sleep at night, wake up in the morning, and work during the day, and you get tired at night. Repeat. My wife is 3 to 11. So I'm going to sleep, she's still doing stuff. But I get up in the morning early, and she's like, oh, reluctant. Let's ask my mom. No, we didn't make any noise till 7:45. We'd be killed. She opted to maximize. She had to be at work at 9. So she maximized her sleep till 7:45. Go, Ruth. And these are types of things with the hypothalamus. Think of them. A lot of obsessive compulsive disorders, eating disorders, not eating disorders, sleep disturbances, emotional disorders. There's a lot that go that are hypothalamic. And we don't know a whole lot about the pineal gland. It makes this stuff, which helps us sleep and wake. I say this every time I talk this unit. You can buy melatonin, Giant Eagle, CVS, Rite Aid, any of those places. Doesn't matter. Okay? If you have trouble sleeping, be careful. There's nothing wrong with taking it. Don't plan until you've taken it a couple of times to do something busy that morning, because sometimes it makes some people are significantly affected by it. It makes them much more drowsy. Some people it doesn't work for at all. You're absolutely right. The risky point is, I got to get a good night's sleep because I got to get up and drive 2 hours to something, and all of a sudden you're falling asleep in the car, and that's bad. That's kind of the point. And now we're in the brainstem, everybody. Hello.
Woo!
Exciting. Thalamus is up here. There's a number of views. This is the midbrain. This is the pons. This is the medulla. We're going to look at all these yellow guys next time. Those are cranial nerves. Really important. From the side, this is coming from your eyes, being processed, and sends it back to the occipital lobe. The midbrain produces a lot of chemicals that are important for the basal nuclei. They play a role in addictive diseases. On the back of it are these two, on right and left, top and bottom, lumps of gray matter. They're called the colliculi, superior and inferior. What they do is they are really important, because if I do this, see, watch what happens. How many people turned their head and looked at me without knowing it? That's a reflex center for sight and sound. That's protective. Okay? It's like you're driving, you hear a siren. Okay? You catch a flashing light out of the corner of your eye. Maybe there's an accident up ahead. That's what the superior is vision, the inferior is auditory.
Is that sort of fight or flight?
Pardon me?
Is that sort of fight?
Not really. Okay? It may initiate it. It's the kind of thing where, look, if all of a sudden you see flashing lights behind you in the car, and it looks like you're getting pulled over, that'll initiate fight or flight. You know? It's like, what did I do now? Every so often, my department chair comes into my office. Lou, I need to talk to you. My first instinct, what did I do? So I go, what did I do now? He goes, no, didn't do anything wrong.
I feel like getting out of tickets.
What?
I feel like you're good at getting out of tickets.
No. My son, my eldest, is great. He takes his military ID. Your dad probably does the same thing. So out of the wallet, when he's saying, let me see your driver's license, and he's opening it up and flashing the military ID is right. They do it. And he figures I might get. He had a first name basis here in Pittsburgh with the traffic court judge. Oh, hi, Adam. I'm here. Glad to see you again. And he called him Adam, and he called him Judge. All I did was, I'll plead guilty, but no points. Oh, God. My boys both like cars that went very quick. Fast cars. Now, moving on. These are the pons, and when we get into here and look at them, it's a lot that you would probably talk about in lecture. These control things you don't think of, respiration, heart rate, all those types of things, blood pressure, and even more so as you get farther down. These reddish areas you see inside the ventricles is where they finalize the cerebrospinal fluid. They're called choroid plexes. So midbrain, pons, and medulla, very much like the spinal cord, but not. And the cranial nerves we'll get to. Let's see what else we can talk about. Those are the visual and auditory reflexes. In the midbrain, and I'll show you the picture, this red nucleus plays a role in neurotransmitters that awaken you. You know how if you have the blinds open and the sun comes out, it might wake you up, or you have an alarm that you hear, like many of us do to get up in the morning. That's basically neurotransmitters produced here. The ones here, this is called the substantia nigra, which means black stuff. Fancy name for what it obviously is. They make neurotransmitters, and you probably learned Did you learn about dopamine and serotonin and all that stuff in AP1? Yes? Okay. Well, dopamine is made here, and that's a lot of people who think Parkinson's comes from an insufficient amount being made there. Okay? And there's not a lot to say about the pons. This is the very big trigeminal nerve. We'll talk about that next time. The ventricle is quite large. That's the fluid that's inside the tube. And then finally, when you get to this is where the pyramids come in. We're getting there. These are these mounds on the interior aspect of the medulla. They are those corticospinal tracts. That's your primary way of moving something. All the rest of these are different kinds of groups that play a role in everything. Again, heart rate, respiration, blood pressure, digestion, all of those types of things. And this is the choroid plexus in the fourth ventricle. Behind the brainstem and in front of the cerebellum is a fairly large vent. You'll see that also on the dissection. And here's the cerebellum. Again, next largest area behind the pons and the medulla. Big player in balance. Okay. Really, I don't do a whole lot about this. The arbor vitae, you must remember this very tree-like pattern. It has more connections almost than anywhere else in the brain. This is really what it looks like. We saw a little bit of this before. Here's that ventricle I was talking about. This is also where the cerebrospinal fluid escapes to go, because not only is it inside the brain area and the brain and the spinal cord, it's also on the outside. You have fluid inside and fluid surrounding. It's almost like the brain's floating on the fluid. And that's the schematic of it, that tree of life thing. And years ago, they saw this and they kind of thought about, I'll show you, this. They actually thought there was like a little person in there. The anatomy said, this must be like a tiny person sort of controlling everything. It's like the great Disney movie, Ratatouille. You know, the little chef pulling his hair. Is this ringing a bell? Great movie. See, my context for things is strange. Nearly done. Almost done. Couple little things, and you can enjoy your. Hopefully, you're all going home, going away, not being here. This year I won't have to. Usually I had like 3 vegans in the family. We had turkey and tofu turkey, and tofam for Christmas. Tofu ham. If you're vegan, yes. If you're not, no. But it was fun to make. Hey, tofu's not bad. Not bad. I mean, I would do. I once did a whole Thanksgiving for like 15 people, and I bought everything at Aldi's. It really works well. Okay, couple of little systems. Okay, the limbic system. This guy. And this is an illustration to be familiar with because I use it. Sense of smell. This is all about emotions. Smell triggers memories. Like I walked into the room today, maybe you did, and you went, ugh. Okay, that's because people didn't empty the red bag. Okay, happens here, but that's a smell, and it says something to you. The same way if you walk into a bakery and go, whoa. Like I was like 2 weeks ago, I was in Oakmont, and I didn't go to the Oakmont bakery. I'm still kicking myself. It's a very good bakery. Pardon me? Where? The Oakmont Bakery. Yeah. Oh. Please. I mean, it's like an hour to get, the number. You get 540. Oh, now serving 472. What? Saturdays and Sundays. This is that cingulate gyrus. Two really important areas. One, this is called the hippocampus. This is on the inside of the brain. You won't see it on the sheep. This is all about memory, particularly short-term memory. This is an area that's affected significantly by people with Alzheimer's. The area, this bulb-like structure here, is called the amygdala or amygdaloid body. That is a rage center. When people have anger management issues, there. Memory issues, hippocampus. So, and a lot of, maybe it plays a role in psychosomatic illnesses. People think they're sick, etc. Memory, obviously, as they're saying here. The reticular formation, that's what I was telling you about before, where visual things or somebody shaking you or pinching you, with that, or making a loud sound, turning the lights on. That's why it sends signals to the brain to wake you up. Okay, you're almost done. We don't do any of this stuff. That's lecture, or amnesia. EEGs is lecture. Did you do that yet, or are you planning to do it with seizure disorders and stuff like that? Okay, it's very, very complicated. Very complicated. More people have this than you think. To be very honest with you. Okay, and this is all fainting, and to me, brain death, REM, and all that, I don't do. So we skip all of that. I do it in lecture. This is really important. Last item for today. The meninges, or meninges, however you want to pronounce it, the covering of the central nervous system. It is different, and when we come back next time, before we dissect the brain, we'll briefly look at the spinal cord, or I'll send you something, maybe even better, about the spinal cord. And what it is, everyone, is these are layers of tissue. And again, it's in threes. You have, and so I actually probably have a brain that has some of that, but I typically use it with our advanced class because they're more expensive. Not that I want to be cheap for you, but I'm trying to, I would pull one of them out for a demonstration with that class, and we probably used it. They are really important. Meningitis is an immediately life-threatening disease if it's bacterial. They used to require the students have an immunization for that. Perhaps they still do. Meningitis? I do not know. Pardon me? Yeah, and a lot of schools did, to be fair. Okay, that's a disease you do not have a lot of time with if it's there. If somebody suspects that, you have to address it now. Okay, moving, and I talk about it for you in micro, we'll talk about it a little bit. So they are the layers. It's different in the spinal cord than in the brain. Okay, because the brain, you have a skull. Spinal cord, you have the spine, the vertebral canal. So it encloses everything, and it's filled with cerebrospinal fluid. And there are three layers. The outside layer is called the dura or dura mater, which means hard matter or hard material. What's adherent to the brain is called pia mater, or spinal cord, soft or delicate. You can't even peel it off. It's almost integral. And in between, there's a layer called arachnoid, because it has little strands that look to anatomists like a spider web. Hence the name arachnoid. This is the illustration you see. It's very hard to duplicate it, even with a dissection. What's interesting about the brain is the dura mater has a layer that's adherent to the skull called the periosteal layer, okay, and has a layer called the meningeal layer that's more adherent to the brain. And it has little gaps. That's the critical issue. Those gaps basically house blood in something that you get to in blood vessels called sinuses. Here, and what projects into them are these arachnoid granulations. You see the arachnoid with the little strands, like a spider's web, and the pia adherent to the brain. The cerebrospinal fluid is in here. So we make about a pint every day, and we have to lose a pint and return to the circulation. These act like little siphons. So like an overflow valve. So if you know what an overflow valve is, when you put too much fluid in something, some of the fluid will have a place to go. It feeds into these sinuses, and so you're making it, and when you have too much in here, it feeds in here, and it goes back to the heart, and basically it's all recycled and reprocessed into different fluids. So it's a critical diagram. So you can have, this is called the subdural space underneath. There's a little space there that fills with blood when someone's struck in the head or gets a concussion sometimes. So they may get what's called a subdural hematoma. And if it's too, and you were asking about the stroke before, if there's too much blood there or fluid, you actually have to punch a hole in it and drain it. Most commonly, the big blood vessels sit in that arachnoid layer right on the brain. That, if you get blood in there, it's called the subarachnoid hematoma. They're the kind of things, so for many of you going into nursing, when there's suspicion of a concussion, it's an awful thing when little kids clunk their heads. You have to tell a parent, you have to do neuro checks every 15 minutes. So it's like every time Junior goes to sleep, you got to wake him up every 15 minutes. Because if they start to the warning signs, projectile vomiting. So if all of a sudden they wake up and, like that, watch out. That's pressure on the brain. And you got to run them back to the emergency. So they want you to check them, and you can't give them anything stronger than Tylenol, because stronger medicines depress respiration. It's insane. So the periosteal and the meningeal layer, which really covers the brain, this is just a layer on the skull, not in the spinal cord. Sinuses are there. You're going to see the partitions on the brain, possibly. They're called septa, and they're fairly thick, and they're called falx, F-A-L-X. And I'll try to get one out that has the dura if I can find it. So you can see this layer is kind of thick where it's there. The arachnoid, again, the granulations, that's sort of like little siphons, as I said, and the pia itself. And here's the meningitis nugget. So it's a cushion. So it's buoyancy. The brain's floating on fluid and surrounded by fluid, and it reduces the weight, because otherwise your brain would sink into the foramen magnum and would be terribly damaging. Okay. Cerebrospinal fluid, you'll get into a lecture, similar to plasma but different electrolytes. That's in those choroid plexes. That's kind of where it's finalized. And this is how it flows. They show you. It's made where these are where blood vessels come in, and it's kind of finalized. And in this area, in the fourth ventricle between the brainstem and the cerebellum, there's like on this two like areas where it could come out in the sides, and one in the back. And that's how it goes from inside to outside. Also, all the way down to the bottom of the spinal cord, there's an opening that allows. This is one of these plexes look like. These are ependymal cells you probably covered in lecture. They have cilia, so they generate flow of the cerebrospinal fluid. And this is what happens when there's a blockage. This can be dealt with. They can put a shunt in if there's a blockage, and you can do surgery too, if you get to it soon enough without brain damage that are there. And I think that's about everything. And the difference, there's a little difference when you talk about concussion and contusion. In the brain, a concussion is by definition temporary. You hear a lot about that. In football, they're in the concussion protocol, maybe a week or 2 weeks, they're back. Contusion implies there's damage from the trauma, and you can get bleeding in there or swelling. In the spinal cord, it's reversed for whatever reason. Spinal contusion usually just means some type of trauma and sometimes temporary loss of function. Concussion, longer term. If you recall with the Steelers some years ago, there's a great middle linebacker, Ryan Shazier, who's now gained almost everything back, was immediately paralyzed. They feared for his life. When students asked me what's going to go on, when I heard it was a spinal concussion, I told them, they said, is he ever going to play again? I said, no. Because there's always going to be some degree of damage. So you'll see him on the sidelines. He walks. He's a really good person and all those types of things. He's just really a good guy and all of that. And then this we talked about before with ischemia, lack of blood. So there's a lot of things that can cause it. And what happens when there is a stroke, it alters the cell. They release glutamate, which is why people develop spasms. It's called spastic paralysis. They can't move it because the muscles are in spasm. Flexors, always stronger than extensors. And the difference between people erroneously call these mini strokes, no such thing. Oh, grandma had a mini stroke, which is fine. No, a stroke means break. She might have had a stroke and there was no damage. I'll buy that. But if she had a TIA or a TIE, it's an alarm clock. It means something's going on in there. Deal with it. And we have ways of, if we get to it soon enough, this is something you'll cover in blood in AP2 that helps you. We now genetically make this clot buster called tissue plasminogen activator. And this is the nugget about Alzheimer's, and I'm not going to go there. But look at the difference between this scan, normal, and that scan. Parkinson's, again, dopamine, Huntington, etc. All right, enough. You can't stand me anymore. I'm trying. Working. Trying. I hope I pass the audition.